A very quick review on thermodynamics unit 2, heat and work. What is work? Work is said to be done by the system if the sole effect on the things external to the system can be reduced to raising of weight. However, weight may not actually be raised. Sign convention, work done by the system is taken as positive and work done on the system is taken as negative. Some points to remember: work is a path function and inexact or imperfect differential. Work is not a property. For quasi-static process, the work can be calculated as integration of PdV. Integration of PdV means area under PV diagram will give us work transfer in that process. Conditions for which integration of PdV can be applied: the system must be a closed system, the process must be a reversible process, and work should cross the boundary. Representation of various process on PV diagram. PV to the power n is equal to constant. This is a general polytropic process. If n is equal to 0, we will get constant pressure process. If n is equal to 1, isothermal process. If n is equal to gamma, adiabatic process. And if n is equal to infinity, constant volume process. And all these processes are shown in this PV diagram. Closed system work in various processes. For constant pressure process, isobaric process, work done is P del V, that is P into V2 minus V1, or it can be written as Mr T2 minus T1. For constant volume process, integration of P dV, work done will be equal to 0. For isothermal process, work done is equal to P1 V1 natural log of P1 by P2 or P1 V1 natural log of V2 by V1. This P1 V1 can further be written as Mr T1. For adiabatic process, work done is P1 V1 minus P2 V2 upon gamma minus 1 or Mr T1 minus T2 upon gamma minus 1. For polytropic process, work done is P1 V1 minus P2 V2 upon n minus 1 or Mr T1 minus T2 upon n minus 1. For open system, the work done is minus integration of VdP. Minus integration of VdP means the area of the curve with pressure axis or y-axis. You can see in the figure. The closed system work is obtained by plotting it on volume axis, and open system work is obtained by plotting on pressure axis. This is the difference. Heat or specific heat ratio. Heat is basically the form of energy that transfers across the boundary by the virtue of temperature difference. This heat Q is equal to mc del T, where C is the specific heat. If the heat is transferred at constant pressure, it will be mCp del T.